Today I will be discussing Physics Lab 4, Oscillations. In this lab we will be exploring the motion of a vertically oscillating mass. More specifically, we will examine the motion of a spring mass system in which the mass swings in an arc while it also oscillates. We will then compare the predicted computational model in GlowScript with the actual model as seen in Tracker. We will plot these energy changes that are computed in the model, which includes changes in gravitational potential energy, spring potential energy, and the total energy. It was found that there was not a significant difference in the x-axis motion, which indicates that the change in total energy is 0. Some of the key physics concepts used in this experiment were, again, Newton's second law, which is also known as the momentum principle. It states that momentum is a measure of mass in motion and can be found through the product of mass and velocity. So the F net equation, which is change in momentum or change in time, states that the net force of an object is a change in momentum over the change in time. The velocity update formula is also shown, and the position update formula, which shows that the final position equals the initial plus average velocity times time. In this experiment, the energy principle is also important. The change in energy of a system is equal to the work in the surroundings plus heat. And in the system, there will very likely be kinetic energy, spring potential, and gravitational potential energy as indicated by the equations below. The other forms of energy include thermal, electrical potential, and rotational kinetic, but those won't be used here. The free body diagram here shows how the spring force pulls the spring back up if it's extended and down if it's compressed, and the gravitational force points down. The system is Earth. The surroundings are none because we're only focusing on the spring. So the system is Earth and the spring, and the change in energy of the system is 0. The sum of all the energies is also 0. This shows the graphs for the motion of the spring. The upper one is the x graph and the lower one is the y graph. The start time is 0. The initial position is also shown as 2.61, negative 4.634, and the initial velocity is 0. The time of the last observation was about 6.8 seconds. The code here shows the initial conditions. As we know, the gravity constant is 9.8, the spring force 6.83, the initial one is 1.123. And then this next one shows the gravitational force, spring force, net force, and momentum principle calculated. These are the graphs for the computational model. They show the change in energy as well as the y position and the x position. So the change in the gravitational potential energy and the spring potential energy in the energy versus time graph were represented by opposite signs, and they oscillate. The position versus time graphs show that the model is relatively accurate at predicting the x position. The y position versus time graph shows that it's not as accurate as predicting the y position relative to the x position, but this could be accounted for by the fact that drag was not accounted for, and the minor differences such as through thermal energy and inconsistencies with where exactly the center of mass was placed in Tracker. All of this means that the energy principle was satisfied. The sum of the change in the individual energies, such as kinetic, gravitational potential, and spring, equals 0. The total energy is 0 because the sum of the potential energies is exactly opposite to the kinetic energy of the moving object. The average oscillation period in the x direction is about 1.6 seconds, in the y direction is about 1.4. So the difference is about 0.2, and this difference has an impact on the spring force calculations, finding potential errors, and calculating the spring's potential energy. Thank you.